Okay, the disk table space, you guys all familiar with this table space, right? It is pretty much the same as this table space in most of DBMSs. In Altibase HDB, the smallest unit is called page. So as you can see from the diagram, the smallest square represents a page. Okay, that is the minimum unit of saving records and indexes, and the size is 8 kilobyte. The extent is the unit for allocating pages in disk table space. The square with 4 little squares inside, that is extent. Okay. So when saving the data into object, it is allocated by the unit of extent. Okay, not the page. Meaning, if there are not enough free pages, then this table space allocates page in a unit of extent. Okay, not the unit of page. Okay, the unit extent has 64 pages, so 64 times 8 kilobyte becomes 512. Therefore, the size of single extent becomes 512 kilobytes. A segment is a set of extents. The red square in a diagram represents a single segment. So single segment is logically the same as one single table or an index. Okay, when you look at the diagram, there are some free pages. The white one is in the used pages, the green ones in red square. That is because the page is allocated by extent. Okay, the allocation of space in this table space. For this table space, the space is allocated to tables in 512 kilobyte units. Okay, like memory table space, the page status for this table space is also divided into free and use. That's because even though their space is allocated by extent, the minimum unit of saving data is a page. Okay, so just like memory table space, when a page is free in table space, in table, that it means they do not have data inside. And when page is used, that it means the data is already in table space or in a table. All right? But to reuse them, the table has to return the page to the table space when it is in table space. But for table, the data has to be deleted. Okay, for this part, I believe you have noticed that the page status is changed same way as memory table space. Okay, so when delete statement is executed, the page status is changed from used to free. And that page is reusable only within the table. That is because when delete statement is executed, the page is not returned to the table space. However, in memory table space, when compaction is performed, the page is returned to the table space, so that space can be reused by other table. But in this table space, the compaction cannot be performed. Okay. Okay. The truncate statement, it deletes the data just like delete statement, and the page status is also changed from used to free as well. However, unlike delete statement, the truncate returns all the free pages to the table space. So other tables can use that free pages by being allocated from the table space. Okay, like I said before, the move is the DML that moves the data from one single table to another table. Okay, this function has the same effect as delete, meaning the free page is not returned to the table space. So that page can only be reused within the table. So because the compaction cannot be performed on this table space, we recommend adding another data file when there are not enough free spaces in this table space, or back up to this data file first and execute truncate statement, or increase the max size of the data file. All right. Okay, now we're going to have a look at the types of segments. There are 3 types of segment, and they are table segment, index segment, and undo segment. The table segment, the most basic means of storing data. The index segment stores all the data for one single index. You guys know what index is, right? For some of you may not know, the index is used to quickly and efficiently provide the exact location of corresponding data. Okay, the undo segment. The undo segment is where original value, the previous value of data is stored. The undo images are created and saved whenever there is modifying operations, okay, such as delete and update. But when commit is executed, these undo images are deleted. Okay, these images are typically used when retrieving the old image when rollbacking the statement, right? Okay, as you can see from the logical structure, the segment is logically saved into tablespace, but physically saved into data file. Okay, so one tablespace can have one or more segments. Okay, so so far we have looked at how spaces are located in this tablespace. Now we're gonna have a look at them in a diagram. All right. Okay, as you can see from the diagram, the tablespace has 4 extents inside. Now let's create table T1. Okay, just like memory tablespace, this tablespace also allocates default free page to the table when table is created. But this allocates page by unit of extent. So as you can see from the diagram, the free pages are given to T1 in extent unit, and also the free pages, the one extent from this tablespace is changed from free to use as well. Okay, now let's try insert. There are free pages in T1 by extent unit. Okay, so the insert has been executed and the free pages from T1 are changed from free to use. Okay, so as you can see from the diagram, the table T1 has no free pages left, so let's try another insert and see what happens. Okay, so when we do another insert statement, the free page, one extent from this tablespace is changed from free to use, and this tablespace allocates other free pages by one extent as well. That is because another data was about to be inserted into T2, but there were not enough free pages in T1, so this tablespace allocated free page in extent unit. Okay, so once the free pages, one extent from this tablespace is changed from free to use, and then extent is given to T1. Now the data is inserted. As you can see, some pages are changed from free to use, but some are not. That is because this tablespace allocates the page by the unit of extent. Okay, now let's have a look at how spaces are returned in disk tablespace. Okay, so as you can see, the disk tablespace has no free pages at all, which they are all in used status. So table T1 and table T2 are allocated with 2 extents each, and their pages are also used as well, meaning there are some data in it. That is why all the pages from this tablespace are used as well. Okay, now let's try to insert some data into table T2. But as you can see, the insert is not working. That is because all the pages in this tablespace are currently in use. So let's try delete some data from T1 to see if free pages would return to the tablespace and data can be inserted to T2. So let's try to delete some unneeded data from T1 and try and delete it by extent unit. Okay, see if that works as well. Okay, now the delete has been executed in table T1. So now the data has been deleted in extent unit and their page status is changed from used to free as well. Now the some pages are deleted from T1. Now let's try inserting data into T2 again and see if that works. Okay, once again we executed insert in T2. Okay, but still it's not working. That's because the delete statement just deletes the data inside the table only, meaning it does not return the free page to the table space. Okay, so remember in memory table space, when we perform compaction, the free pages were returned to the table space, and other table could use that free pages from the table space. But here in this table space, we did try to delete it by extent unit to see if that works, but it didn't. And the compaction doesn't work in this table space. So let's try something different. Okay, so there are actually 3 ways. First of all, we can increase the max size of the data file, or we can back up the data file and truncate the table T1, or we can add another data file to the table space. So here we're going to try add another data file to the table space. The third one. Okay, let's see if that works. Okay, we're adding another data file. So once we add a data file, now we have some free pages in this table space which are allocated by extent as well. Okay, so there are free pages in this table space. So let's try to insert some data in T2 and see if it works. Okay, now that this table space can allocate free pages by one extent to the table T2. And as they are allocating extent, the extent from this table space is now changed from free to use. And also, the T2 is allocated free pages in the unit of extent. Okay, so data has been inserted into T2. Okay, like I said before, there are free pages in T2. That is because you know the answer is right. This table space allocates the free pages in a unit of extent, not by page. Okay, so we just talked about how spaces are returned in this table space and how to allocate new free pages when there are not enough free pages in this table space. And how the page status are changed in various situations as well.